everyone. Today on your Meet This Morning, you did lesson 3-6 with your math teacher, and you learned about benchmark fractions and you learned about how to check for reasonable answers. We're really thinking about the size of fractions, and we use certain benchmarks to help us to do that. There are three main benchmarks that we usually think about. What are those three benchmarks? We think about 0, we think about 1/2, and we think about 1/2. If you take a look at the number line poster that is on my slide here, you'll see that this number line also extends to the number 2, which is fine. So we could add some new benchmarks as well. We could think about 1.5, and we could think about 2. These are numbers that are friendly numbers that we should understand how to think about, and they should help us with fractions that might be a little bit more challenging. So for example, if you take a look at my number line poster, I should be able to use it to compare the sizes of fractions. For example, which is greater, 2/3 or 3/5? By looking at the number line, I can see that 2/3 is greater. Which one is greater, 1/6 or 3/9? By looking at the number line, I can see that 3/9 is greater. However, we want to be able to do more than just look at the number line. We want to be able to think about the size of the fractions. So on this journal page, I'm looking at journal page 85. If you don't already have out your math journal, please go find it. You can pause the video at any time if you need to. On journal page 85, we have this fake student. His name is Christopher, and it says he solved some fraction problems. And we're trying to figure out if his answers make sense. Basically, you're playing teacher today to see if this student named Christopher did a good job or not. There's a math problem. He makes a conjecture, which is basically an answer based on the evidence that he has, and we need to decide if it makes sense. So here we go. Number 1, 2/7 plus 1/2 equals 3/9. Now, just looking at that quickly, what do you think Christopher did to add those fractions together? It looks like he just added the numerators, 2 plus 1 equals 3, and then added the denominators, 7 plus 2 equals 9. That's not how you add fractions, and most of us know that. However, that's not really what we're looking for today. Do you think it makes sense that 2/7 plus 1/2 would equal 3/9? Sevenths are not on our number line, but 1/2 is, and so is 3/9. So I'm going to take these red dots and I'm going to slide them over. There's 1/2. And here is 3/9. So even though I can't find 2/7, I'm looking at these dots and I'm thinking to myself, if I already have half, and then I add something to it, does it make sense that my answer would be 3/9? Yes or no? No, it doesn't really make sense. So you can go ahead and circle no in your journal. And I want you to type in a few sentences for me. Why doesn't it make sense for 1/2 plus another 2/7 to give me the answer of 3/9? You should probably say something about how 1/2 is already bigger than 3/9 and we haven't even added anything to it yet. If I'm going to add to 1/2, my answer should get bigger. It should not get smaller. All right, let's take a look at number 2. This is a comparing fractions question. Christopher thinks that 9/10 is greater than 7/8. Now let's take a look at our number line to see if this can help us out. I'm going to drag this red dot over to 9/10, and I'm going to drag this one over to 7/8. Perfect. Does it make sense that 9/10 is greater than 7/8? Yes or no? It does make sense, and I can see on my number line that 9/10 is just bigger than 7/8. However, I don't really want to use that for my argument. I want to talk about the size of the fractions. Take a look at 9/10. I'm 1 away from the whole. And think about 7/8. I'm 1 away from the whole. Can you think of an argument as to why you could prove that 9/10 is greater than 7/8? For this one, it's really about the size of the pieces. I'm only 1/10 away from a whole if I'm at 9/10. and I'm 1/8 away from a whole if I have 7/8. The bigger the denominator, the smaller the fraction. So if I'm 1/10 away versus 1/8 away, I know I'm a little bit closer to 1 whole. That's why 9/10 is greater than 7/8. All right, let's take a look at number 3. This is another addition problem. It says 7/12 plus a fourth equals 8/12. Now there's a couple ways we can look at this one. I'm going to start with my dots. Let's go ahead and find 7/12. Let's find 1/4. And let's find 8/12. Interesting. 7/12 and 8/12 are very close together. They're on the same number line. So if I had 7/12 and then I added a fourth to it, does it make sense that I would have 8/12? No, it doesn't really make much sense. When I look at the size of 1/4, that's a pretty big jump. And if I added that to 7/12, I would definitely jump over the 8/12. Now for this problem, 7/12 and 8/12 are pretty easy to compare because they have the same denominator. So can you come up with an argument that would explain why 7/12 plus 1/4 would not equal 8/12? You would probably want to tell me something about how you know that 7/12 and 8/12 are on the same number line and they're only one jump apart. So that means that 7/12 is only 1/12 away from 8/12. And by looking at my number line, I know that 1/12 and 1/4 are obviously not the same amount. So I know that this could not be true. Let's go to question number 4. It says 8/9 plus a third equals 8/12. Do we think that's true? Well, let's start with the number line just to get an idea in our minds. So I'm going to find 8/9. I'm going to find 1/3, thinking about the size of these fractions. And if I add these together, supposedly my answer is going to be here, 8/12. Does that make sense? No, I would say it does not. If I already have 8/9 and then I'm adding more to it, there's no way that my answer is going to get smaller. There's no way that I'm going back down to 8/12. Go ahead and type in your argument. Why doesn't this answer make sense? Great. Hopefully these made sense to you. Hopefully you understand how to use the benchmark fractions. Let's practice a couple really quickly together. For example, can you tell me which benchmark is 1/8 closest to? 0, half, or 1? That's right, 1/8 is closest to 0. Take a look at your number line. How about 7/9? Is that closer to 0, half, or 1? That's right, it's closest to 1. Now, what if I wanted to compare two fractions? Which one is greater, 5/6 or 2/12? Of course, 5/6 is greater. If I look at the number line, I can see that it's further to the right. However, you also should have thought about those benchmarks. 5 out of 6 is pretty close to a whole, whereas 2 out of 12 is pretty close to 0. So even without looking at the number line, you should be able to figure it out. This number line in the back of your math journal is a great resource for you whenever you need it, and I hope that you take advantage.